Hey guys, today we're going to learn how to graph linear equations. First, we need to understand what a linear equation is. A linear equation is any equation that can be written in the form y is equal to ax plus b, where a and b are both real numbers and x is a variable. A linear function creates a continuous line on the xy coordinate plane like the photo shown below. The variable a determines the slope, or in other words, the rate of change. On the other hand, the variable b indicates the y-intercept of the function. The y-intercept is the y value of the function when x is equal to 0. Alright, so let's get straight into graphing. Here we have the equation y is equal to 2x plus 1. Now we can see that this is in slope-intercept form, meaning that we can find the slope and the y-intercept of the function. So to plot a linear equation, what we have to do is we have to plot out 2 points and then connect a line in between them. So the first thing we're going to do is we're going to search for the easiest point, which is the y-intercept. Now here we can see that we have a b component of positive 1. Now that means that our first point will be at 0, 1, because the b component is whenever x is equal to 0 and y is equal to the b component, so this positive 1. Next, we have to find another point. So to find another point, what we have to do is we have to choose any other number other than 0 because we already plugged it in. So any other number other than 0, which is simple, and then find out its y value. So let's say we plug in 2. Well, 2 times 2 plus 1 is equal to 5. So that means our x will be 2 and our y will be 5. Here we have 2 points, 0, 1, so 0 on the x and 1 on the y. And then we have another point, 2, 5, so 2 on the x, 1, 2, and 5 up. Now all we have to do is connect the line, or connect the dots with a line, and draw an arrow on both sides showing it's continuous. And that's it, there you have it. Now let's graph an equation which is in standard form, or in the form of ax plus by is equal to c. Now there are 2 ways of plotting this simply. The first way you can do it is if you're comfortable with slope-intercept form, then what you can do is you can solve for y and then use that equation to draw the graph. But what I like to do when I have it in standard form like this is we find both intercepts, the x-intercept and the y-intercept. So to do that, what we're going to have to do is we're going to have to plug in 0 for both variables one at a time and then solve. So here, let's look for the y-intercept. Now the y-intercept happens when x is equal to 0, so we're going to plug in 0 in for x. So we have 4x plus 5y is equal to 20. So when we plug in 0 for x, we get 4 times 0 plus 5 times y, which is equal to 20. Now 4 times 0 is just 0, and then we have a 5y. Now if we want to solve for y, what we're going to have to do is we're going to have to divide 5y by 5. So if we divide on both sides, let me scroll down a bit. If we divide 5y by 5, then they cancel out, and we do it on both sides to keep it balanced. We get y, let me do it up here, y is equal to 20 over 5, or in other words, 4. That means that our y-intercept is at 0, 4. So we have this point 0, 4. And next we want to find the x-intercept, or where the function hits the x-axis. To do this, we're going to have to plug in 0 in for y, and then solve for x. So we have 4x plus 5y, and y is 0, so we're going to plug in 0 for that, is equal to 20. Now 5 times 0 is just 0, so you can forget about that, and we're left with 4x is equal to 20. Well, to isolate x, what we're going to have to do is we're going to have to divide both sides by 4, so these two cancel out, and we're left with x is equal to 20 over 4. Now 20 over 4 is just 5. That means our x-intercept is 5, because that's our x value, comma 0, because that's what we plugged in for y. 0 point is going to be 5 on this x-axis, so 1, 2, 3, 4, 5, right here. And all we have to do is just connect the dots, like this, and draw an arrow to show it's continuous, and there you have it. Now, we're going to be doing the opposite of what we did before. Before, we are graphing an equation based on a function given. Now, what we're going to do is we're going to take parts of a given graph and turn them into a function. We are going to achieve this by using a form, just like standard form and slope-intercept form, but this time the form is called point-slope form. Now, point-slope form is y minus y1 is equal to m, or slope, times x minus x1, where x1 and y1 are the points that we're given. So here what we want to do is we want to plug in the information we have into this point-slope form. So y is just going to stay the same. Now our y1 point is this 4, but it's negative, see, because we have a negative over here. So it's going to be y minus 4. Now we have our m, which is our slope, and that's given, that's 2. And then we have times x minus x1. Now our x1 point is 1, so the opposite of that, or the negative of that, is negative 1. That's what we're going to plug in. Now we have y minus 4 is equal to 2 times x minus 1. Now we're just going to simplify this. What we're going to do is we're going to distribute this 2 with the x minus 1. So 2 times x is 2x. And 2 times negative 1 is negative 2. Then we have y minus 4 on the other side. Now what we want to do is we want to isolate this y to bring it into slope-intercept form, like we originally did. And what we're going to do is we're going to take away this negative 4 by adding 4 on both sides. So this cancels out, so we're left with y is equal to 2x minus 2, and then we added 4. So minus 2 plus 4 is just plus 2. So this would be our equation. Now let's say we want to finish the graph, completely draw it. Well, what we can do simply is just use our slope to figure out the next point. So we know that the slope is the rate of change, meaning that for every 1x, y will increase by that number. So here we have our slope as 2, so for every 1x, our y will increase by 2. Well, our previous y was 4, so 4 plus 2 is 6, and our previous x was 1, so if we're going to move it one more time, then our x will become 2. So our next point will be 2, 6. And then there you have your 2 points for the graph. You just draw a line and arrows to show it's continuous, and that's it. For our last example, we're going to be finding the equation of a line based on 2 points given and without any slope. So what we're going to have to do is we're going to have to take these 2 points, plug it into a formula, receive our slope, and then plug our points back in with the slope to find out our b value for this slope-intercept form. So before we start, we have to understand one concept, which is called the rate of change, or rise over run. So rate of change is rise over run, and rise means the change in y value, and run means the change in x value. So our rise is going to be y2 minus y1 over x2, which is our run, x2 minus x1. So our y2 is our second point subtracted by our first point. And we're only doing the y values. And the x1 and x2 are the x values of our first and second point. So this shows the distance, or the difference between these 2 points. So what's going to happen is we're going to be plugging in these points into here. So our y2, it doesn't matter which order you put it in. I'm gonna go as our y2 is this, or our 2 as our bottom set. So we have our -2 right here, and our y1 is 4, but it's negative. So it's going to be -4. Same thing with the bottom. Our x2, let's put it as -2. And then we're subtracting -5, meaning that we're adding 5. That leaves us with -6 over 3, or in other words, -2. This means that -2 is equal to our slope, or our m. Now what we're going to have to do is we're going to have to choose a point and then use our slope to figure out our b value. So let's say we choose this point up here. So if we plug in -5, we're going to receive 4 according to this function. So our y value is going to be 4. So 4 is equal to, our slope is -2. Now, typically you'd see x plus b, but again, we don't know our b value, but we do have an x. Our x is -5 right here, and then plus b. So what we have to do is solve for b. Now, we know that -2 times -5 is just positive 10. So we have 4 is equal to positive 10 plus b. Now to solve for b, what we have to do is we have to bring this positive 10 to the other side. So we're going to subtract 10 on both sides. And that leaves us with -6 as our b. That means the equation for our line is going to be y is equal to our slope, which is -2, x, because it's a function, and then plus b. Our b is negative, so it's going to be -6. And this is the equation for our line. That's it for today. If you have any questions, email me at neark15@gmail.com or ask it in the comments below. I also run a Google Classroom, which goes over many important topics in Algebra 1 and includes worksheets created by teachers and me, videos, and other resources that are useful to students. If you would like a video on any certain math topic, ask in the comments below, and I'll make sure to look into it. Have a good week.